For me, it's a pleasure to introduce you to Thomas Ferguson. That is towards feminist arithmetic. Thomas, it's a pleasure for us that you stay here. Thank you very much.
Thank you. It's 1 hour and then questions?
Yes.
Okay. So I'm going to shoot
30 minutes for discussion.
Okay. Okay, so hi, thank you for having me out. It's nice to see you all / meet some of you. I'm so happy. This is like one of my favorite places in the world. Let's see. Okay, I'm Thomas. I'm going to talk about feminist arithmetic, which is cool because it's like the only place I can do it and not have to give like half an hour of apologies prior to speaking. I still will make a bunch of apologies, but this is joint. I'm working on this with 2 people, Monique Whitaker, who is in my cohort.
What is that cohort?
My PhD cohort.
Oh,
Yeah. And Vita Kadlachikova, who is my PhD student at RPI. I guess administrative things. I'm super happy. If nobody's been asking questions in the middle of talks, but if there are anything or comments, or you want to shout at me or something, please like raise your hand or just openly shout at me. That's totally cool. I'd rather hear you talk than hear myself talk. So that's an invitation to you. And also, I'm skipping class, the first week of classes at RPI to do this. And so I'm, as in lieu of giving a lecture to students at RPI, I'm saying you can watch this YouTube video. So if you do shout me down, try and make me sound really cool because I'm going to tell them to watch this. So, okay. Now the way the slides. Clicker works this way. Okay. So what I'm going to talk about is first, I'm going to give you a spin on Meyer's project of R sharp of relevant arithmetic. So there's going to be a little bit of mathy stuff in this. Sorry. And I'm going to do this as follows. I'm going to first talk about why I think it's important that we actually go and try and give a penetrating feminist analysis of arithmetic in something that starts approaching a Talmudian arithmetic. I do want to say that I'm totally on team Val on this, and I'm going to use the word feminist in her sense, where I guess when I say feminist, you can also just do this liberationist or something like this. So what feminist means, I guess I don't really know if I can get into, but I mean what Val means because Val's awesome. I want to talk about how we can move the critique from logic to mathematics. And then I'm going to give some background about another love of mine. I don't just love Val, I also love Bob. So I'm going to give you some background about Bob Meyer's relevant arithmetic. Suggest that formally it starts actually seeming like it is an authentically sort of Talmudian feminist arithmetic. And then I want to actually sort of mine some elements from the development of mathematics that suggest not only does R sharp kind of formally capture this stuff, but there's actually, if you reflect on the development of mathematics, a lot of these Talmudian concerns are actually kind of cooked into the development of mathematics itself. Yeah. And then, okay. So background. There are for lots of different disciplines, there are all sorts of, oh, actually, wait, I want to tell a story of this. Why I started thinking about this in the first place. And the reason yes, I should tell the story. Okay, so I went to a conference one time, and there was a talk that was given about feminist epistemology and computer science, right? And I was super stoked about this because I am through and through a constructivist. Like I'm not only on Team Val, I'm not only on Team Bob, but I'm also on Team Brouwer in many ways. And there's a lot of stuff in Brouwer that suggests that, like, when we're making these constructions, that in principle, like, sort of our social position and the cultures that we grew up in, that these might play a role in the construction of mathematical objects. So I sort of just hope this is going to be a kind of nexus that, like, maybe situated epistemology would have some kind of insight into different variations on computability. Right? What might it say about Turing's thesis? Like, this seems really interesting. So I went to the talk. I was very, very eager. I was younger and more doe-eyed. And the talk essentially went as follows. The speaker pointed out that there is a representation issue in computer science, that there's not a lot of women getting degrees, and wanted to use feminist epistemology to tell us how we can fix that, how we can increase representation. And essentially, the upshot was that doing a PhD in computer science, or doing a master's in computer science requires that you do a lot of stuff like learning how to program a computer and learning how to get a background in discrete mathematics. And if you want to do machine learning, you have to learn statistics. And all of these things are things that women are good at. So what computer science PhD programs need to do is start catering to what women are good at, like art and doing Photoshop and stuff like this. And this certainly is a very depressing kind of comment about like what feminist epistemology has to do with computer science. But when I walked away dissatisfied, I did ask myself, like, what talk were you expecting to give? What was the talk that you wanted to see? Because I can't really very well criticize something unless I have something to put up in its stead. And that's sort of where this came from. It's like, what did I expect to see? Well, if nobody else is going to do it, I'm going to try to do it. So this is where this came from. There is, I think, a really interesting gap in terms of how feminist critiques approach like a priori disciplines like computer science and mathematics and logic versus the inroads that they've made in other disciplines, right? So these critiques that you see, I mean, they can vary in a lot of different ways. They're on a spectrum. I mean, there's different aims, there's different scopes. Sometimes they're more penetrating, sometimes there's something more pragmatic in their scope. And you have, I mean, sort of, this is a huge spectrum right here. Like this famous Haraway thing, it sort of made this observation that in primatology, for example, pretty much the conduct of primatology had just taken the male of all these primate species as being a sort of avatar for all others, and it completely warped the view of primatology. And when Haraway pointed out, well, we need to actually take into account like females of the species and their behavior, kind of turned primatology on its head. Is my understanding of this. But on the other hand, you have things like Henrion, who goes and looks at something in like mathematics, and she focuses on issues of representation. Like, how do we take the observation that the women are underrepresented in like faculties? How can we make sure that we increase hiring, tenuring, and retaining female faculty? And both of these are being authentic feminist critiques of a field. But I want to say that one is sort of more penetrating. It goes to the foundation of what pharmacology is. You're doing it wrong. Henrion is like, look, you're doing everything right, but how do we make sure that we can bring more women to the table? And there's a huge difference. Both of those are legitimate projects. There's a huge difference. And we tend to find that when we look at things like sociology or biology or medicine or psychology, last year I took Butler's Gender Trouble as my jogging book that I listened to. And like, what's this? Just completely takes down psychology because of all these gender assumptions that they're making. But like these fields, I think, in the wake of feminist critiques, have had a sort of radical reshaping, and that you don't see when you go to computer science. When we look at like feminist critiques of computer science and the a priori disciplines in general, they tend to be there's a question mark there. But the critiques tend to be very pragmatic in their scope. They tend to be concerned with pedagogical issues like, are we teaching to women in an appropriate fashion? Are we attracting women into these majors? Are we attracting women and making sure that we have appropriate tenure decisions when they go into faculties? And there's sort of a handful of exceptions. The question mark was Franchi's dissertation, which is like a tour de force. Franchi Margraviti. But I mean, almost like if you go and you look at all the volumes on like what feminist critiques of mathematics, they're almost entirely focused on just these sort of shallow, important but shallow representation issues. Garb also has a nice line that sums it up. At least, I mean, this is now I guess a little bit dated. Clearly, from many people in the room, this is becoming more dated. But I strove to find all discussions of mathematics from a feminist approach. And I found only interesting and hopefully influential, it's important still, discussion of pedagogical issues surrounding the teaching of mathematics to boys and girls. This literature is mostly focused on educational settings. I was not able to find much theoretical writing on mathematics and feminist philosophies. So this point of intersection, although it's had noble goals and again, hopefully influential in its scope, has remained sort of shallow in comparison to other fields. So then what we need to ask is there a need for a more radical critique of mathematics? And if there is a need, then how could it be actually executed? What would it look like? Yes, okay, so clearly, right, I mean, the development of mathematics has been largely writ by the hands of white men. And if this fabric that, through the development of mathematics, is in fact contains some kind of oppression, right, then I want to say that the sort of shallow mode of critique isn't sufficient. We can't, there is oppression that's baked into mathematics, then just increasing the participation of underprivileged groups, it's not going to actually fix the issue. And there's a lot of writing on this that sort of underscores this. There's a beautiful line that Hooks writes, and this is about Supreme Court justices. She's reflecting on, like, you could have a Supreme Court of all women, it's not necessarily going to get you where you need to go. But Hooks writes, willing groups of men are willing to endorse equal rights when it is clear that the women who enter spheres of power will work to uphold the status quo. Such women will exercise power alongside men, even as they continue to support white supremacy, capitalism, and patriarchy. These women validate the concept of power as domination and control and exercise it, while assuring men that their masculinity is in no way diminished. So merely increasing representation without having a thorough sort of, resetting of the foundations, it's not necessarily going to be sufficient. And in the context of the a priori disciplines like mathematics, you have reflections of this sort of bell hooks-like consideration. Right, Nye, considers, like, we can't just increase participation because that participation is going to be conditioned on women's thinking like men. According to Nye, I don't think I agree with Nye on things a lot, but I mean, it's a concern. Is concerned about the participation because the critic herself will be devoured in the process by entering into this debate with, like, the mathematicians. So this theme is, I think, present in the considerations about feminist thought and mathematics itself, and a priori discipline for general. Will be okay. So what we've been trying to sort of set out is that 3 points, right? One is that the concerns that Plumwood makes, in fact, do lift the cases of the a priori disciplines. So the same things that Plumwood remarked when it comes to just logic itself, that these things, in fact, impact and apply to critiques of computer science, mathematics, and so forth. We want to make the case that Bob Meyer's work on relevant arithmetic, it makes for a very nice starting point. It's not the end of the road. It's not clear that R# is the feminist arithmetic by any means. But it's a very good move in that direction, and it demonstrates, it's a proof of concept that these sorts of things that are Plumwoodian in nature are going to be possible. And that Plumwood-inspired critique of mathematics, if you actually reflect on the development of mathematics, there's actually a need for it. The Plumwood concerns are present again and again in many episodes in the history of math. Okay, I want to make a claim that, I want to partition sort of a lot of critiques of logic into just two sort of modes, and this is an incomplete slide. There's a couple of ghost slides. Sorry. And I'm going to call these abrogationist sort of critiques, in which we take the critique takes logic to be just completely unsalvageable as a project, and that, like, deductive reasoning has to go, versus what Plum would call the negationist techniques that says that stop short of indicting the project of logic as a whole, but rather take issue with the way that negation operates and reject negation. So Nye is sort of the hallmark person that takes this abrogative critique. So rejecting the use of logic in toto is contradictory to feminist aims. And in words of power, Nye, it's very clear. I've spoken about this. The relations between speakers. That logic, there's a missing word here, are alien to feminist aims. It's not possible to argue that these are misuses of logic with feminist logic incorrect. There is no feminist logic on the abrogationists line. They just have to go. Logic has to go. Negationist critiques, right? This is Plumwood's term, are those that say that maybe some positive reasoning is okay, like positive syllogism might be okay, but the use of negation itself is inherently oppressive. Again, because they're not familiar with any alternative but classical negation. And like these, we see like Fry's necessity differences points us out in both frames, existentialist and Lacanian. To be a woman is to be not self, not man, not the phallus, or phallus. Further ways of constructing the social ontological category of men as the A side of the universal exclusive dichotomy, A versus not A, both Irrigare and Beauvoir want to liberate women from the consignment of the not-A side of such a dichotomy. These dichotomies occur, they're inherently all dichotomies, not just dualism, but dichotomies inherently are oppressive, and the solution is to get rid of the not. So, given how closely related deductive reasoning is connected to the developments and the operation of these a priori disciplines, it's indispensable. I mean, I'd be shocked if you would be able to tell me that you can have mathematics without deductive reasoning. But both of these sort of critiques of logic sort of lift to induce corresponding sort of theories of arithmetic or mathematics in general. Right, so you would have, following from an abrogative critique, you would have like a sort of abrogative mathematics that would follow from this. So Nye, and I'll have a quote from her, she seemed to really actually bite the bullet on this and say that, okay, yeah, you know, deductive reasoning itself is sort of oppressive. It's totally cooked into a lot of these formal disciplines. And so these things themselves are sort of things that have to be cast aside. The problem with sort of an abrogative mathematics is that it's going to be extraordinarily high. I mean, the cost is going to be high. I mean, you might have an axiom. You might be able to tell me that every number has a successor, but you can't do the reasoning that's required to instantiate it. So like, it's going to maybe, you can have a mathematics in some sense, but it's going to have no dynamism to it whatsoever. And as I said, Nye sort of bites the bullet on this. In the concluding pages of Words of Power, it takes us not just the philosophy classes, but women still struggle, if not with crime, other texts with computer programming, statistics, economic models, and so forth. So Nye really seems, I mean, you know, give it to her for, you know, having the courage of her convictions on this. But it seems, you know, like computer programming and mathematics, that these things kind of have to go as well. Negationist critiques then, like of logic, are going to introduce corresponding theories about mathematics. And there's going to be some mathematical practice. I mean, you can have an axiom that if two numbers share the same successor, then they're identical. And you can do some reasoning about these sorts of things. So a sort of negationist theory of mathematics is going to be slightly stronger. It's going to have some dynamism to it. But when we're thinking about the fruits of mathematics, applied mathematics, like it's very hard to see what we could do without having a notion of negation. If I'm an engineer, I am just as concerned as when two quantities are identical as when they differ. I mean, if you want me to build a bridge and I can't ever tell you if two spans are of different lengths because I can't use negation in my engineering project, I wouldn't trust that bridge very much. Right? So a sort of gerrymandered negationist engineering seems like it'd be very difficult to sort of, oh, maybe untrustworthy. Yeah. Okay, but Valhoma's expertise on non-classical logic, sort of in the just logic domain, allows her, right, to sort of evade the trap of these two modes. Like she can have something else, and from this, okay, yeah. Sorry, I'm make sure I have this. Okay, yeah. So she can avoid the abrogative negations traps. Right, so Plummet, I mean, I'm sorry, that's kind of redundant because you spoke a lot about these things yesterday. But the issue to Plummet is not just that we can make dichotomies. Dichotomies are okay. I can build my bridge and I can say these two quantities are not equal to each other. That's fine. It's when they become offensive, right, because of this centering that occurs. That is when we start rethinking our theory of negation. And on Plumwood's account, we totally are able to do that. I have two growth slides where I talked about radical exclusion and homogenization. Two of those themes that, as Roy showed, sort of correspond to non-contradiction and excluded middle. And these are sort of hallmarks of the sort of relevant negation that Plumwood embraces. And I'm going to skip past because we talked about it. Okay. Well, no, I mean, these two things together are features of negation. The fact that I cannot have anything and its other in the same theory without complete system collapse. That's an important thing. Homogenization, that if you're defined in virtue of the sort of standard, if it's centered on the P, all of the not P's are going to be homogenized. They're all going to be just some sort of amorphous mass. And the way I like to think about this is they sort of work in tandem. I mean, like radical exclusion is a sort of violent mechanism that rules out the other from having full participation, and homogenization is sort of this propagandist, is the way I like to think about this, where the other doesn't require any kind of protections because there's no quality to being the other. So it sort of legitimizes the sort of radical exclusion of the other. But I don't want to get into that. It's sort of superfluous. Okay, so needless bleeding to mathematics, though. The kinds of classes that Plumwood is concerned with, right, are like social kinds primarily. I mean, the sort of the hierarchical dualisms that she points out to are things like colonized and colonizer, and you know, man versus not man, and these sorts of things, male versus not male. And you might think, well, this mathematics is too abstract and remote from these sorts of concerns to be the locus of such centering, right? I mean, even numbers are sort of opposed to odd numbers, but it's kind of hard to make that a civil rights issue, that there's an opposition there. So I think that you could take the Plumwood thing and be kind of incredulous that we need to rethink mathematics on account of it, because that sort of social tension that you have in these constructed classes doesn't appear on its face to be part of the domain of mathematical thinking. But from this fantastic paper that somebody in the room wrote, right? It's not just totally localized, though. The sort of excision of these things isn't, we can't just say it's all okay, but listen, in a couple of special cases, we need to really be careful about how we apply negation, right? The Plumwoodian critique is more global in its scope. And logical systems, as Maureen and Charlie Donahue wrote, themselves include domination. It's not just careful applications that are required, but the rejection of systems themselves as they are unsalvageable, right? So it's not just, we'll use classical negation all the time, but hey, just really, you need to put on you need to put on the mittens when you're applying it in the social category. It's really, there's something incredibly wrong about classical negation itself. And I think that there's a sort of acclimatization that occurs that would make us think twice about using classical negation in mathematics. For negation to be a sort of tool of oppression doesn't mean that I'm actively using it in order to oppress, right? Just indoctrinating students to just use it as the default mode for not is sufficient that it becomes normalized, right? If I teach if I'm in a math class and I'm teaching the students about, I mean, and I guess this is kind of your point the other day as well. I'm teaching them about, expulso, right? Indirect proofs, and I'm not saying, listen, you can only use this in this domain. Be careful about how you use expulso in other domains, right? I'm teaching my students not just a mathematical operation, I'm teaching them a linguistic operation about how not works. And then they leave the classroom, and they become acclimated to this use of not. And then they leave the classroom, and ultimately that takes over because an authority figure is telling them this is how you use not in logical reasoning. So upon exiting the mathematical domain, a fully acclimated user, right, might lack or might not default to the more non-oppressive versions of negating that Plumwood recommends. So I think to say it's siloed in mathematics so you don't have to worry about it, I think that kind of fails a Plumwoodian test. Because there's still students, faculty, the public is still being indoctrinated with this as the authentic use of the word not. Yeah, okay. In system collapse, I want to bring up system collapse again. This is going to be important. Okay. I mean, everything clear stuff is okay so far? Okay. Plumwood, the positive reason, the negation of relevant. Okay, yes. Oh, removed. Yes. The negation of relevant logic can be interpreted as expressing a notion of otherness as non-hierarchical difference. The resulting concept of relevant otherness avoids radical exclusion, for the conjunction of A and not A does not induce system collapse. Thus, not A is not homogenized as simply part of the rest, for an account of propositional identity based on relevant implicational equivalence can make fine discriminations among the elements of the propositional universe. A couple of things to point out here. Plumwood is recommending a relevant logic as being a sort of solution to the issues that she addresses. And also, again, this I want to point out the system collapse concern that in a classical theory, if I do find something and its negation in the theory, the entire theory becomes just the language itself. It collapses, everything follows. So I can't do any reasoning in the presence of a contradiction. And what I've been thinking about this now is that you can describe this as a sort of logical fragility. I mean, in the same sort of as a analogy with like white fragility or fragile masculinity, there's a sort of fragility that is invoked when one is concerned about preserving the system in the face of system collapse, right? And I think this is going to present itself as a sort of mathematical fragility when we look at the history of mathematics. So the classical mathematician has this concern, this constant worry, the sword dangling over their head about what happens if something turns out to be inconsistent. Everything goes away. And so that kind of anxiety that's induced there, right? If you have something precious, I mean, what was it, Lord of the Rings, you got golems, that guy's precious, right? You got your precious, like, you gotta go and eat the hobbits, right? And all this stuff. Right? Oh, man. So, all right, said the hobbits. Oh my gosh. Okay, I wonder how this is going to drop the course now. Anyway, no, that's the thing, right? Like the relevant mathematician in principle doesn't have that same golem complex. You don't have to be under constant anxiety. Golem complex, that's cool. I would use that. Okay, you don't have to feel this constant anxiety of losing the thing that you have because you know, even if a contradiction emerges, then okay, life carries on. Like I didn't lose my precious. Okay, so I want to think of this as a type of like logical fragility, and as I said, when we review the history of mathematics in a number of episodes, I think this slips into sort of arithmetical fragility as well. Makes sense? Yes. Okay, cool. It's good. It's rare. Okay, we don't need to go through all the axioms. So, okay, kind of a performance critique. I hope, and I made some case that we do want to actually think about porting these logical intuitions into like mathematics and computer science and so forth. And the question is like, okay, can we do it? And we can because of this awesome stuff that Bob Meyer put together in the 70s through the through the 90s. Well, we're not going to go through all the axioms, but just for completeness, here's an axiom for relevant logic R. It's a very strong relevant logic. Plum would not like it. She does not like it. But Bob liked it. So, axionizing, so Bob introduced in the 70s into privately distributed and unpublished until like last year manuscripts on this relevant arithmetic R sharp. R sharp takes as its sort of deductive basis the relevant logic R, and then it closes the piano axioms of arithmetic under relevant deductive machinery. So, I mean, we're familiar with these things. I know there's some notation here. This prime and successor, what do my axioms say? It says that, like, for all numbers, zero doesn't have a predecessor. There's no number such that its successor is equal to zero. All numbers that are identical have the same successor. It defines recursively what addition looks like and what multiplication looks like. And we have this axiom, we have this rule induction scheme where I know if a property A holds of zero, and I know for all numbers, whenever it holds for a number, it holds for its successor, then I conclude that it holds for all numbers. So R sharp, you just saw R sharp, boom, boom, R sharp. So I want to give some background about Meyer's project because it's awesome. Meyer, well, I'm going to describe sort of some of the issues about it. I want to talk about why it sort of became really interesting and then why Meyer's program kind of collapsed. So Meyer, as I said, in the 70s, they're 21 because Graham and I published them finally, posthumously. But there's two manuscripts. There's one arithmetic formulated relevantly, and there's one the consistency arithmetic. And one thing that marks the distinction between these two manuscripts, which everybody should read because it's funny as heck. Meyer is so funny. But they take very, very different tones, right? The first one is just sort of ecumenical. It's like a latte magnum. It's like telling like the mathematician, hey, come over to my beautiful relevant waters because I have things to tell you and I can make you do mathematics better. Whereas the latter is the sort of rabble-rousing tone, where it's saying, hey, all of that stuff you thought about mathematics, you're all dead wrong, and you're doing mathematics, like the history of mathematics is totally flawed, we've got these bad assumptions, and I will save you from it. So the sort of ecumenical Meyer, right, offers to mathematicians a way of using relevant logic in order to express naturally occurring distinctions that the mathematician makes all the time in her practice, but in classical logic lacks the means to express it, right? So importantly, right, we've got a horseshoe, a material conditional that we have, and in relevant logic, we complement it with this intentional conditional. So how does Meyer try and sell this to the mathematicians? Meyer says, well, look, we may think of the classical truth functional vocabulary as well suited to the expression of facts about the natural numbers, but not oriented at all towards the expression of the laws in virtue of which we discover the facts. Right? So in this material conditional that we have in classical arithmetic, this is a fact-laden connective, Bob tells us. It merely transmutes simpler sentences of fact into a more complex statement of fact. And it neither rests on or licenses any lawful connections between facts so compounded. But of course, good arguments rest on connections and not facts. So we need to have, as mathematicians, we use the distinction of, like, we use the notion of like a law-like entailment, but we don't have the means to express it. And the material conditional fails to do so. The relevant conditional is introduced precisely to take account of these connections, as Bob. And this introduces at the formal level an opportunity to make distinctions which, though perhaps dimly present in the intuitive base, goes beyond it in sharpness and formal clarity. We should add what Bob says is, and it makes this point, we should find cases in which if A and B on the material conditional line, these are provable, when A entails B on the relevant line is unprovable. There are cases in which if A and B is true, but B does not follow from A as a matter of like law-like mathematical operations. Okay, there's some important things about R sharp to talk about, so I'll point out they're going to be important both to the story for Bob and also to the story for how the Plumwoodian sort of interpretation. So Meyer Martin's in 1984, this really great thing, they gave us these finite, inconsistent, and non-trivial models of R sharp in which 0 is equal to 1 fails, right? So these are models in which all of the arithmetical axioms and truths are true, but 0 equals 1 is not true, which means that we can't prove 0 is equal to 1 from R sharp, which sets it up in stark distinction to PA arithmetic, because we don't know. And maybe in PA, if you were Edward Nelson, you would seriously suspect that there exists a proof that 0 is equal to 1 from the basis of PA. Meyer's managed to prove that R sharp is arithmetically correct. It proves exactly the true identities, and it proves exactly the false inequalities, right? So when it comes to like M is equal to N, R sharp gets it right. When it comes to M is not equal to N, R sharp gets it right all the time. And that's something that importantly, because of this fact, we can't say about PA, but we can say about R sharp. So there's a sense in which it's more reliable as a system of arithmetic for equalities and inequalities than PA is, because we know that we're never going to get, at the end of the day, the fact that 0 is equal to 1 is true. So important features to take away: R sharp is post-consistent, doesn't prove everything. And this proof that Meyer Mortensen provides, it's a finite model. So we can prove this finitistically. We can look at the model. It has two elements, and we can see, okay, 0 is not equal to 1 in this. And it's arithmetically reliable. So Meyer understood this in the more radical mode to sort of overthrow Gödel's second theorem. And I think of all the people that want to overthrow Gödel's theorems, Bob's probably the only person that has a leg to stand on this, because he actually has like subtle thinking on it. And he took this to reinstate Hilbert's program, because not only can I show that arithmetic is reliable, but I can do that within the system itself, and I can do that in a finitistic fashion. Okay. Where did Meyer go wrong? Like, why did Meyer's, like, why aren't we all doing relevant arithmetic if Bob was so great in the 70s? And I'm going to say that the locus of this is PA completeness. So Meyer, again, in that arithmetic formulated relevantly manuscript, is making an overture to the practicing mathematician. He's saying, I respect everything that you're doing. You're doing everything right when you formalize stuff. But look, you know, informally, you're making this law-like, the assertions of law-like relationships that hold between arithmetical sentences sometimes, and classical logic doesn't give you the subtlety of expression to do that, but I can. So Meyer respects classical mathematical practice. He wants to provide something to complement it. So it's important for our chart that everything that the piano arithmeticist is doing remains provable in our chart, right? So for Meyer, who has this kind of deferential stance with respect to mathematics, it's important that everything in piano arithmetic remains provable in our chart. But Harvey Friedman, I guess in a dream, according to he dreamed the proof, essentially showed that there are PA theorems that are not provable in our chart. I'm not going to make you look at the formula, but there's this quadratic residue formula, and there are weird models that are models of R sharp, but not models of PA. So this essentially just stopped Meyer's work in its tracks. And one of the things that I really like, loving about Plumwood and loving about Meyer, about doing a Plumwoodian reading of this, is that it allows us to completely sort of reappraise the impact of the Friedman result. Okay, so why might we think of R sharp as a feminist arithmetic? Let me do this in the opposite order. What would be qualified to say that this is a feminist arithmetic? The latter point would be that it has to be free of those oppressive features underlying its deductive apparatus identified by Plumwood. So does R sharp get us all the way? Well, as excluded middle, on the one hand, there's some of these paradoxes with implications that Val Plumwood does not like that hold in R and are inherited in R sharp. So it's not all the way, but it shows that it can be done. And it also needs to be sufficiently strong to support the sort of arithmetical reasoning that we need for just human thriving, right? Manufacturing antibiotics is good. And if you tell me that the theoretically appropriate theory of arithmetic does not allow me to do enough calculation in order to discover new antibiotics, or to make them, or to give them to starving children who are sick, I'm going to question your theory of arithmetic. So I think between these two things, it needs to be sufficiently free of sort of oppression on Plumwood's account, and it needs to be strong enough that we can actually have a good human life. So on this first point, right? Plumwood, I think it's clearly a theory of arithmetic. It clearly excludes the exclusionary negation, and it demonstrates that we can go a little bit weaker to get rid of some of the things like suppression that Plumwood argues about. So, like I said right here, like it also does have some of these things, but it's a good proof of concept that you can do arithmetic while being clear in terms of your deductive apparatus. And minor complications about R sharp come into play. You can do enough arithmetic to go and do all the math that you need, right? To build bridges, do computations, use technology to discover, make new medicines, etc. Right? Because it's arithmetically correct. It's more arithmetically correct. I mean, I know that when it tells me that something is equal to another thing, that it's true. PA doesn't do that. So it does everything that PA can do when it comes to the kind of computation that we need in order to live like fruitful and flourishing human lives. So compare this to the point that Nye makes, or she, again, I mean, bless her for having, again, the courage of her convictions, but I mean, it kind of contrasts with that. Like, Nye's like, yeah, engineering? No, like that's oppressive at its core. So what do we do about PA incompleteness, though? Okay, all right, I'm okay. What do we do about PA incompleteness? So this was like the catastrophic thing that Meyer wrote like hundreds and hundreds of pages in R sharp. He did this beautiful, fantastic mathematical work. The theory of R sharp is so well developed. The philosophy that corresponds to it is so lovely and so insightful. And then you've got this Friedman thing, and then Meyer never touches it again. There's one paper in 2012, I think it's posthumous, that he no, but I mean, it was really like he wrote one time about it again in this like tiny little publication, but it never really developed. So that Friedman result, the PA incompleteness of arithmetic of R sharp is terrible for Meyer. But I think that looking at it again through a Plumwoodian lens, it says that well, what was a bug to Meyer is maybe a feature for Plumwood. And the hinge right here, I want to say, is how they relate to mathematicians. So there's this famous line from David Lewis in Toxic Classes that has been now I think deferentialism is a term that's used for like people that sort of accept this credo, Lewis's credo that we see. All right, Lewis writes that mathematics is an established going concern. Philosophy is as shaky as can be. To reject mathematics for philosophical reasons would be absurd. I am moved to laughter at the thought of how presumptuous it would be to reject mathematics for philosophical reasons. How would you like the job of telling the mathematicians that they must change their ways? Can you tell them with a straight face to follow philosophical argument wherever it may lead? Meyer is totally down with Lewis's credo, right? Meyer is like actively says what the mathematicians are doing should be respected. We need to complement their work, not replace it. He's not Brower. He's not like, look, you're doing it all wrong, man. It's just like you're doing it right. It's just that the way, and this is, I mean, back to Anderson and Belknap. It's not, you're doing everything right in your informal reasoning. It's the classical logicians who are letting you down, right? They're truncating, they're barbarizing your mathematical practice by not offering the tools you need to formalize what you're really doing authentically, right? So Meyer's totally down with this credo. So of course, being incompleteness to Meyer is catastrophic. I can't any longer observe this credo if I have to go to the mathematician with the straight face and say, oh, actually, because I'm a relevant logician, you're doing your job wrong. On a Plumwoodian line. That changes the entire standpoint with respect to Lewis's credo, right? On the Plumwoodian line, right, the fact that we indoctrinate mathematicians into the use of a weapon, not its negation, even if it's not actively being used as a weapon, that's something that yes, if the mathematicians are doing something oppressive, then by all means, you can go to them straight face and you can say, listen, there are social costs to what you're doing. There are downstream effects to what you're doing. And you know what? Like, so you can still do all that. We can still do all the bridge building, but like, there are these social costs. Yes, you need to change your practice. So almost not that much, right? That's a huge point of distinction between how the two thinkers kind of stand with respect to mathematics. And to summarize that point, like Romano's commitments meant that he had little choice but to defer on a Plumwoodian of R sharp, Plumwoodian reading of R sharp. The philosophy of mathematics has little choice but to resist. Right? Huge distinction in that. And what that means is that the same reasons that Bob Meyer found R sharp to be not worth pursuing makes it worth pursuing to a Plumwoodian. Okay. Time. Okay. All right. Good so far?
Yes.
Makes sense? Okay. How words of feminist arithmetic? Yeah, so we've got these sort of perceived pathologies, and there are some other differences that Meyer's 2012, and I think I'll mention this, goes on to talk about some other differences between stock PA and R sharp. And for one of the deficiencies, I mean, you can go back, I mean, Zach has written a number of really nice things about this, about paraconsistent mathematics, like, don't be afraid of it. If you're a mathematician, you like to explore. You're a mathematician, you like to go to new vistas. You're like Captain Kirk, right? You want to go to strange new worlds, right? Paraconsistent mathematics allows you to do this on Zach's line. Well, all of these things that are pathologies to Bob Meyer are just new vistas to go and explore as a mathematician. As mathematicians, that's what we like to do. We like to go to find new structures, right? New features are old structures. And I think that Zach sort of talked about this, sort of applies directly to how we can receive R sharp. Okay, one thing that I think is interesting, and again, 10 rules. Oh, I've got 16 by my count. We can fight about it in 16 minutes or 10 minutes. Okay. All right, I'll pick it up. Okay, one of the things in this 2012 paper, fallacies division, that is really, I think, interesting is Meyer, in a more sober tone now, goes and he looks at an interesting difference between R sharp and PA. Right, Meyer used this formula 0 is equal to 2 implies 0 is equal to 1 as an illustration about how this thing fails in relevant arithmetic because there's not a law-like connection between the two. And it uses that as a point to sort of differentiate between R sharp and PA. And then we consider this argument by Gerd Mueller about how to actually deduce 0 is equal to 1 from 0 is equal to 2 in a way that looks law-like. And I'm illustrating like some of the details, but like Meyer gives a simpler version. It's like, listen, a more direct way in the law-like fashion to reach a conclusion that 0 is equal to 1 from 0 is equal to 2, simply divide both sides of the equation through 2. So you get zeros equal to 2, divide by 2, 0 is equal to 2 implies, I'm sorry, is equal to 2 is equal to 2, which, I'm sorry, that should be equals, means 0 is equal to 1. That seems like a law-like sort of thing. So Baumeyer's like, well, okay, well, listen, like I can give you a sort of law-like proof of how to infer this. This is a problem for R sharp. But here's the interesting things, right? Baumeier writes, this holds classically just because 2 is not equal to 0 is an immediate consequence by instantiation of the initial axiom for all x's successor is not equal to 0. In the standard systems, not A entails A implies B. So 2 is equal to 0 implies B for any B in these systems. So the critique that Meyer gives is, listen, your law-like path from these things that involve division actually start looking very irrelevant. Not A entails A implies B. So this sort of principle that not A entails B is a sort of tacit fallacy of relevance that's getting baked into that division argument. But in another formulation of this, what is this?
Yes.
Not A is equal to B. That's radical exclusion. So one of the kind of interesting things about this, I think, I mean, I'm not going into super details here. Read the paper. My statement is really good and accessible. One of the cool things here is that what this shows is that this fallacy division that Meyer considers, and he's like, well, it seems kind of irrelevant, but doesn't have a really good argument for like under the hood what's going on. Well, if you look at it through a Plumwoodian lens, it's radical exclusion is what's going on. Okay, so R sharp differs from PA in an important way, but if we sort of we look at it a little bit and change the terms around, it's again the difference between pure arithmetic and R sharp is a reflection of this Plumwoodian issue, right? It's radical exclusion that's under. So yes, maybe there are arithmetical differences, but it's interesting that when we find them, we can go and recast them in Plumwoodian terms. Okay, so the TLDR. R sharp, authentically demonstrated arithmetic. I still have another section to go. It remains reliable enough for arithmetical goals. We don't have to throw out the baby with the bathwater. And the Plumwoodian reading often applies directly tiny differences in arithmetical behavior to Plumwoodian themes, as we showed. Like when you have differences between PA and R sharp, frequently we can go back and say, okay, aha, that's a Plumwoodian point that he's making right there. It's a Plumwoodian point that's making things different. Okay, so you could take a position from what I just said. Okay, I, Thomas, have taken some formal conditions endorsed by Plumwood, and I want to make sure that your formal system that satisfies the conditions. You could just say, cool story, bro, right? Okay, whatever. You showed this formal system. Like, these are other symbols. So the last, I don't know, maybe 8 minutes, if I split the difference, is that we can reframe these sorts of things, to show that this isn't just a formal thing. If you go and you actually look at the number of episodes in history of mathematics, like this isn't just me providing an axiom system that gives some sort of desiderata correct. Rather, like there is classical question. So I'm going to use, and these things are more talky, so I'm going to go by these pretty quickly. All right, so I mentioned logical fragility. I think that there's something that we can observe that's sort of arithmetical fragility. That's when I've got my mathematical thesis that I'm holding onto, and somebody imperils it, and then I need to latch out at all costs. I need to go and contort myself into whatever shape I can in order to preserve that thing. So oppression is often expressed in reactionary terms as a fruit of fragility, right? The panic experienced by a dominant group at risk of losing its position. And this fragility is often expressed as anxiety. And I want to talk about a couple of cases that I think, I want to say put meat on the bones of what I said, but it's probably a really, give a more like better narrative to some of the more formal points that I've just made. So these anxieties resulting from the fear of losing one's precious status, they're common in the history of mathematics. These anxieties are expressed by clinging to radical exclusion, as we'll see also. This Plumwoodian theme of radical exclusion, when we look at all these episodes of this anxiety that we get in the history of mathematics, there's just very, like, we need to exclude the other at all freaking costs, seems to be the theme, right? So, case one, Gödel's incompleteness theorem. I think we're getting recast the sort of Gödel's incompleteness theorem in a lot of these same terms, right? So the anxiety sort of happens, and if you look at the tenor of accounts of the fallout over Gödel's incompleteness theorems, The language that's being used is very much, you look at like work on like fragile masculinity, it's very, 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 very similar right here. So Klein is beautiful. I love this book. I love this book so much. But writes about the fallout of Gödel's incompleteness theorems, and just think of the language here, right? Gödel's results were shattering. The inability to prove consistency dealt a death blow, most directly to Hilbert's formalist philosophy. However, the disaster extended far beyond Hilbert's program. Any day a contradiction could be found. Whereas all of mathematics could be pointless. Mathematicians working under a threat of doom. That sounds like original. I would have gotten into the school of my choice, but they discriminated against me because I'm white. I mean, it sounds very, very similar to that kind of language right there, right? And there's also, so case one, it's like just if you look at, not necessarily contemporary, but you look at the kinds of languages used about this and the fallout for the mathematicians in the wake of Gödel, like the language being used is often very, very amplified and very, very nervous about losing status. Hilbert doesn't want to lose status to the Hilbert program. Nobody wants to lose the status. And Dedekind in contemporary language makes this very, very clear. This is the beautiful, beautiful letter that he wrote. So model theoretically, Gödel's theorems are, right, you think about them frequently proof theoretically, but model theoretically, they are tied to the failure to be able to prove omega categoricity of piano arithmetic. That is, that I can't fix my model to just be my counting number 0, 1, 2, 3. They're always going to be, I can't rule out that there are non-natural or non-standard natural numbers that make true all my arithmetical axioms. Okay, almost there. Okay, so hanging down the standard model, though, like wanting categoricity in model theory is what would advantage any other contenders. I mean, that's a radically exclusionary sort of categoricity is inherently radically exclusionary, right? I need to have these intended numbers. All of the other ones I need to get rid of. I need to send them off to some island where I don't have to look at them anymore. And all right, lest you think that I'm just like blowing smoke. And it's somebody, how Wang translates this, but again, look at the language here. What must we now add to the facts in order to cleanse our system as arithmetic from such alien intruders, T, which disturb every vestige of order, and to restrict ourselves to the system of natural numbers, right? Like, they're alien intruders. They disturb every vestige of order. I mean, if this is not radical exclusion, I don't know what it is, right? Think about AM talk show hosts, right? Think about like little commentators. I mean, like, wow.
The immigration crisis.
I'm on camera. I'm trying to be very much. So in this paper, we quoted Franci's dissertation on something and asked her to think about like, and she wrote back, they wrote back, and asked that we change the quote a little bit because they had a concern that they would end up on Fox News. They're publicized this time. Okay. Any case 3, promise on ending, group logging preset, right? You think about the Russell set, right? We've got baseball 5, we can build any set given any property phi. And we've got this Russell set. Okay, it's paradoxical. The Russell set belongs to itself and does not belong to itself. So you've got naive class theory. It's a beautiful, intuitive, precious theory. You've got the Russell set, which disturbs every vestige of order. What do we need to do? We need to get rid of the Russell set. We need to somehow, and all of the developments are, I'd say, almost contortionists, like ramified theory of classes. You think about like ramified classes. You think about like the ramified syntax that goes into like new foundations, cure for this, like the kind of contortions that we have to bend ourselves into in order to get rid of the Russell set, to preserve our pure land of like, this naive set theory, or like at least something that, more closely resembles like Frege's promised land. We have to radically erase the objects. And it's funny, the degree of baroqueness to which people are willing to go for that. All right, piece 4, focus round. Yeah, all right. This is worth it. Okay. It's not just stuff in the 20th century. Pythagoreans, right? this, beautiful, almost religious position that all quantities are these harmonious ratios between things. And then what happens, right, to the Pythagorean worldview? Along comes Hippasus of Metapontum, right, who is credited with proving the irrationality of the square root of 2. So what does the quantity square root of 2 become in this beautiful promised land? It's an alien intruder, threatening every vestige of order. And what do they do to him? Vanish. No. They kill him. They murder him. They throw him over and drown him. That's how much you need to banish the square root of 2 as a quantity. The people that go ahead and say, we need to go in, we're throwing over a board and drown them because they were aiding and abetting, right? Okay, so point here, and now I'm not over time by my clock, but now I'm over time. Point here, TLDR, could present the crisis occurs in the development of mathematics. There seems to be a common format here. And it seemed to very much admit a Pomeranian analysis. We have a dominant sort of group. You've got a dominant theme. You've got some kinds of things that threaten to interrupt that order, and we need to get rid of them at all costs. And we need to get rid of them at all costs through the sort of negation. So negation is the problem in these cases. So an impulse towards homogenization and radical exclusion, I'm going to suggest, forms sort of a pillar of traditional mathematical practice. So the point there is not just that our chart does it, it's also that if you look at the history of mathematics, this kind of underlying system further is what would be necessary to move more closely towards something approximating an authentically Pomeranian arithmetic analysis. Okay.
Thank you, Thomas.
Thank you. Okay.
Okay, it's time for question. Okay.
Yeah, I just wanted to just make a comment on some of the stuff that came in the motivation early on. And sort of this idea that we have to clean the classical logic. It seems like this is really important with the feminist project, feminist logic, feminist math projects. Is there's this default burden of proof issue, right, about logic. Right. And it seems like until you start doing this stuff, right, and Williamson's very explicit about this, especially in Vegas book, right, that classical logic is the default, right? And we have to give really good reasons if we're going to give up that clean, clear, simple, powerful tool. And I even remember reading this at RK in a reading group, and Stu and I were very confused. And Stu had a good line. He's like, no, excluded middle should be something you earn, not something you assume. Right. And I think coming back to this background and thinking more, I mean, that just got me your background stuff. This has nothing to do with the real project of your paper, but I think it's important. Like thinking about what the terms of the debate are, right? If it's really that we have to give some positive argument that classical logic is bad, rather than just saying no. I mean, we're just going to build the right, the good logic that does the that supports the liberatory things. That we want to do. I mean, it seems like there's some really interesting like terms of the debate thing going on here. And similarly for math, right? I mean, you sort of tell people you're going to propose like these alternative mathematics, and they're like, no, it better be like preventing nuclear war level concern before we can ever consider not changing mathematics or telling mathematicians even in any minimal sense that they're doing something wrong, right? It seems like that's not actually once you have the feminist stuff on board, that's the terms of the debate are just different. And I think that you brought that up, and I think that's really important and worth more attention.
It reminds me that when so I always hoped secretly that PA would be inconsistent. I don't know if you remember, this is 10 years ago, Math Overflow was going crazy because his proof was out there. Edward Nelson's proof was out there, and I was just like, I'm not smart enough to go through the proof. But I was just hoping that Terrence Towers, somebody would be like, okay, actually, yeah, it's inconsistent. I was hoping. Because then everybody's hands are forced. So your house is totally burning down, my friend. Are you gonna go and sleep in the immolation, or do you want to go over here? Right? And and they make debating a lot easier.
Yeah.
But thank you.
Yeah.
I don't think I had any.
No.
Yeah, other than I don't know. I would like you to tell me the Williamson work though. So I could.
Oh, it says things like this in a number of places, but it's very clear in a passage in the vagueness book.
In the which book?
In the vagueness book.
Oh, Vegas. Okay. I just said Vegas.
No, Vegas. I've never done that yet. You question a lot.
All right. Thank you. Yeah.
Okay, Mariana?
This might be a naive question,
I'm a
but
naive person, so okay.
where does the problem begins? In math or logic? Because I'll give an example. As a math student, an algebra teacher once explained to us, because we were in first or second semester, I don't remember, we were new. And he said, Gödel's problem is something like this. It's like you are in a room, you need to find a key, and you don't even know if the key is there. So I went through school thinking, well, it's not a big deal. It's more a feature than a bug. For the advanced students, it's more a bug than a feature. But for us, first semester, second semester, it's a feature, not a bug. Then I got into philosophy, and everyone was fighting about Gödel and axioms, and it needs to be complete logic, and everyone was fighting in logic and in philosophy. But as a math student, only the most advanced mathematicians were fighting, and not that much.
And then past that, then if you're doing professional models of analytic, you're willing to write a 450-page book, knowing that it could all be trivial. So yeah, so like at the end of the day, it makes pieces again, yeah.
I have friends that do very, very, very advanced math, and they might say something like, well, I don't agree with the things that you're using, but I know you can assume that they are true, and I don't care. I agree with your process.
Yeah, I mean, there's an element of debate that goes on.
Yeah, so my question is, where is the problem, in math or logic?
I mean, I don't know the differences between logic and math, I guess, for one. I mean, look, whether or not there is a problem is, it feels like a practical decision that you have to make. I mean, what were the little, like, remora, so the things that, like, they clean the sharks, right? The sharks are going around, this little fish cleans them, right? They're pretty well fed, right? They're pretty well fed. They get down to, like, the jaws of the shark, and they're eating all the leftovers and everything, and they're having a nice life. They get eaten any day. Get chopped up by the thing that feeds them any day. But yeah, those are good. Right? I mean, there's something kind of similar to our standpoint with respect to the Gödel theorems. Like, okay, when I was a kid, I'm old-ish. Well, I had nuclear war drills about stuff because we're worried about the communists sending a nuclear bomb to Chicago, and like we'd have to get under desks because that's what you do when there's a nuclear bomb, is you get under your desk. But I was like 8 years old, I started in constant anxiety about, oh my gosh, is this the day? The air raid sirens would come on, like, is this the day we get vaporized? Okay, I can get vaporized. You know, what am I doing? Like, why am I fretting over it? I'm not gonna change it. And I think that there's a sort of similar consensus with mathematicians. Like, okay, Gödel's theorem show that maybe we'll prove it to be inconsistent one day. Somebody's gonna be a smart aleck and can show it. But like, we're not, like, we should just keep on doing what we're doing until that day comes. Yeah, I don't know what the problem with logic or mathematics. Like the way that you express this, I thought was really nice. Like when you're you know, undergraduate or high school student or something, and you're learning arithmetic, it's totally fine with it. Maybe you know there's some kind of issue, you don't have to pay attention to it. You're a graduate student, and you start, okay, you actually kind of need to worry about this stuff at some level, and then you become a professional mathematician, and you're like, okay, I think that's piece of it again. Yeah, so I don't know how to answer the question of where the problem lies, because I think it's just the way that human beings deal with danger and risk. It's like you have to make these kinds of decisions. Can I answer your question? I don't know if I did. Sometimes I don't answer those questions.
No, but it may anything more, so intuition is similar to an answer.
Okay.
Okay.
If you're happy, I'm happy. If you're not happy, I'm happy.
It got me into a good track of thinking, so I'm happy.
Oh, that's a good thing to hear, thanks.
Thank you, Marina. Gillian?
Okay.
This is gonna be a little sort of big picture and a bit vague, so I'm gonna try to make it as clear as I can, but I'm sorry if it's vague. So I was really intrigued by the analogy between kind of exclusion in the political realm and sort of fragility kind of stuff, white fragility, masculine fragility, and then the examples from the history of mathematics. So stuff like the Russell set and irrational numbers and things like that. And so, you know, I definitely see some of that, like almost like similar emotions being expressed by the mathematicians, similar fears. And they seem like clear examples of cases where we were afraid of things we shouldn't have been or excluding things that we shouldn't have been. But one view you might have is, okay, what's going on there is we're excluding the wrong things, right? It's bad to exclude women, it's bad to exclude irrational numbers, you shouldn't be afraid of the Russell set, things like that. But we still want to be able to exclude bad things. Like we still want to be able to say, these are the good proofs, these are the bad proofs, and we shouldn't be doing those ones. We still want to distinguish between like good and bad in mathematics or good and bad in politics. We still want to be able to exclude injustice, and racism, and sexism. And sometimes, in fact, we need exclusion, but why not exclude the bad stuff for relatively good? We can draw the line in one place.
So I think, look, I mean, I totally concede this, and this touches on a whole lot of stuff, like meta theory. Like, I mean, you have these things with non-classical logics in general. Like, are you gonna like you're espousing a particular view at the object language, and then all of a sudden you just completely change your philosophical position when you're doing meta theory? Like, come on, like that touches on what you've said. And yeah, I don't want to go into overdrive and like say, okay, we. Like, Plumwood excludes classical logic. But one might even say she radically excludes classical logic in a sense. But is that a kind of inconsistency for her? Or would that be an inconsistency for what I'm saying? I am not totally. I think I've kind of tried to wrestle in my head with things that you're getting at. The best I can say for now is that I think that there are probably ways of avoiding something or sidestepping it without radically excluding it. Like I can take an opposition view that I disagree with, and I don't have to demonize it nor to cast it out. I can just say, no, like I refuse to engage. I deplatform. There are options of that are not like this sort of incendiary, like you are the other, you need to go. And like, I mean, there's like a kind of political element to this sort of thing, which is like, how do you treat the opponent in these things? And I would hope that there's a more ecumenical way to do that. So yeah, I mean, I totally admit there's something kind of incoherent about saying, listen, I'm rejecting classical arithmetic. But on the other hand, the rejection is the problem. There's something just like very incoherent about that. But I think the mode of rejection, the mode of setting up the sort of dichotomy there might have something to do with it. But I don't have a really well thought out answer to that. But it's a difficult one. It's a really difficult one. But I think it goes back to Plumwood as well. Like Plumwood seems to very much say that it is this ability. It's like this weapon of radical exclusion that's the problem, not just any particular use of it. I mean, you're in the quote from it thing.
The difference between dichotomies and dualisms is kind of clear that there's ways of being not true without it being a classical decision of true falsity.
And maybe that's where I'd want to go. I mean, if you're a white supremacist, maybe I want to set up the dualism there. I don't I don't know, I want to be ecumenical in all things. And I try very hard to be ecumenical in things, but I recognize that there are positions where like, yeah, you need to radically exclude certain groups. I don't know, do you have any suggestions? Or like, am I misunderstanding, like?
No, I think, I mean, I'm struggling to, formulate my question in a really sharp way, but you said things that are sort of helpful, thank you.
Okay.
And I did see it as a question for Plummet as well as for you, it wasn't just for you.
Yeah, I think that sort of point in range sort of touches on it. My intuition is to go with that it's not just othering something, it's the mode of othering. And like, I don't have to go and burn down the Fox News station, I can just turn off Fox News. Maybe, I don't know, maybe.
Okay, but people can do that to women as well, right? I'm still not happy with that.
Okay.
It's like they may not be othering me, but they're still not letting me speak, that's, where I sort of paid.
Yeah. I hope my dad isn't watching. No, yeah, thank you. I totally think this is a totally legit point, and I'm not super equipped to deal with it, but not for lack of trying. So that's what I can say.
It's okay. I can practically the same worry, but instead I'm gonna try to instead of keep pushing that direction, go somewhere else that I hope is helpful. I'm going to start with an anecdote.
I like anecdotes.
Yeah, because going back to the discussion about whether representation is kind of shallow, but this is deeper.
I should have said shallow.
Yeah, you didn't say shallow.
Okay. Oh,
You said that.
I said something deeper. I didn't know how to phrase my discussion of it, but yeah. Okay.
No, it was like a few weeks ago. Helen Mambino was here, right? Well, yeah, it's here, there, in the same place where you are. So I asked her, like, why did she think that there is so much feminist work on sociological theories and biological and medicine, history, economics, and not mathematics, logic, right? And I thought she would say something about how the content of the theories is differentiated. It's less natural. But her response was like immediate and very sure. She was like, because there are not enough women in mathematics and logic that would raise these questions. So it has nothing to do with the content. It has to do with the people, right? So that it is not that the way you kind of put it, the hierarchy in the inverse way, right? So if we need to first be willing to do the groundwork of having a more pluralistic mathematics or logic in order to, so that when the people get diversified, they can do work that is actually radical. But she was presenting it the other way around. That in order to get the more profound or the more contentful criticism of mathematics and logic, we need first to change the constitution of the people who are doing it.
Yeah, I mean, I'm surprised.
Yeah,
It's
I'm very
very-
surprised as well. Yeah.
So, I mean, for one, like you don't like more work has to be done than that, right? That bell hooks line. I mean, you see this other places.
Yeah.
I think it's just very, very clear that you can indoctrinate people into serving as capos, essentially, right? And that's not representation alone doesn't get you anywhere if you're indoctrinating your newfound friends into the same system of oppression that you're fomenting.
Yeah, but I think what she's questioning is that is a very big if, right? That she doesn't think that de facto that is what is happening. The system is not as robust that it's changing the people, or that it's selecting the people who would not be doing the change. But that people who come in are not being indoctrinated. They're coming to people, diverse people who are coming into these spaces that were not diverse, are not being indoctrinated despite what people like groups have said a priori.
Well, and I agree. I mean, like, political change is a much different beast than arithmetical change, right? I mean, very different things. I mean, did you get any insight into what the eventual mathematics would be to her mind? I mean, like, does mathematics itself change when you have more representation, or does it just proceed, but you've got more like evenly distributed faculties?
I don't know, she wouldn't say, but because of her larger framework, it would seem that first you change the methodology, but first it's okay, maybe I'm being too schematic. But as you change the people, changes the methodology, and only in the end you would change the results. You would change the theory. I don't know if that's helpful.
It seems helpful at the very least. If not necessary, if not the
Yeah, it seems to
a good thing to have. Yes, I do not disagree that that's important. Agree.
Yeah, but okay.
Yeah, thanks.
Okay, we have time for third question. Luis and Loading.
I have 3 questions.
Sorry, it's goodbye.
Good. I was a bit lost about to what extent R# is fluid, because you made a case for this fact of dealing with explosion in some form. But maybe I skipped that part. But what about excluded middle? With this R# is built into R.
We ignored several, several items.
Yeah.
Pretending of being the plummeting method, it satisfies it to the middle, which I think plummet should like. And it satisfies a number of principles not related to negation like suppression. And so yes, it is not the plummeting, it is closer, and it charts a course towards something like, okay, MCQ sharp is going to get you closer, but something like B sharp, that might be too weak. We can start looking at how to fix the underlying system.
Too weak, you mean, for this sort of applications and getting drugs?
Yeah, I don't know anybody that's looked at B sharp. Maybe somebody has. I'm not aware of it.
But what about BK sharp?
Yeah, I mean, you could, or GG sharp. I mean, like you've got uncertainly many opportunities right here to fit something. Yeah.
Not in the sense that there is some work in that paper.
Oh yeah. I mean, Ross has done so much in MCQ sharp. I mean, there is robust work being done on this, and so yeah, I do not mean to offer R sharp as the solution, but rather a proof of concept that says, like, now we can take our techniques from relevant logics and we can more closely examine what Plumwood says about other things and try to fit it. And now the question is then, it's a fitting issue. How do we balance enough mathematics to do the work that we need to do so we can still have a mathematics and yet satisfy as many of the desiderata that Plumwood has given us as possible? Like, how do we fit that? So maybe it's not. I mean, maybe you find out that, like, there is no suppression-free arithmetic for what, you know, like maybe that this is a start. This is not the conclusion of the no. But yeah, R sharp, I think it's the middle should go. R sharp has it, right? I think a lot of things should go. But this points that there's a trailhead, and now we can follow the trail. Did I answer you?
Yeah.
Okay.
Second question. I'm far from being an expert on R sharp.
You published on it?
I systematically doubt about collapses and all that sort of things. I remember this Friedman proof of the collapse of R sharp in the sense of comparing it with linear arithmetic. And again, I don't remember the details of that proof, but it looked very relevant from start to the end. There were very suspicious contrapositions at some point, proofs by contradiction, and the other uses of this geometric syllogism there. So I say, well, this is a collapse of Meyer's program in a sense, and Meyer accepted it because he was too classical at some point.
But one of the positions in, right? Like Meyer's like,
yeah,
intuitive, informal mathematical reasoning is good. So, yeah, look, I don't know if it's relevantly acceptable, and I mean, I've talked to Zach about this, like, there's some suspicious moves in there, but Meyer is still committed to informal mathematical reasoning is good. It is always relevant, and so there's sort of, I totally agree, I don't know, I think that testing out the Friedman thing in a relevant meta theory is totally a project somebody needs to do, that person is smarter than me. But that needs to be done, and I think that could be a really, you could end up at the end of the day, yeah, like, that's not a model for R sharp, because the techniques you need to show to be a model go outside of relevant reasoning. Yeah, absolutely good point, but I mean, phenomenologically, I mean, that ends it, right? I mean, that, like, Meyer writes the R sharp paper, right? Meyer writes 2 things about this, and like the last one, the 2012, it's like, yeah, he's just like done with it, like completely goes through. Unfortunately. Yeah. But yeah, I want somebody at some point to do that because it's super important. Thank you.
No, thank you.
Okay, Ori,
Fast. So
please.
I've been working on Plumwood and the paper coming out, I have a problem for what I call recentering. And it has to do with looking at how Plumwood's understanding feminism coheres with intersectional feminism, very contemporary things, where centering itself is no longer this demonized term. In fact, it appears very vividly in things like transformative justice, so that, you know, instead of white centering themselves in black spaces, things like that, where centering now has this much more productive meaning for protecting and centering like the voices of trans people when trans issues are right. So I mean, I think it's kind of the converse, like with of Jillian's problem in a certain way. Like her comment made me think, well, within Plumwood's view, there's just no place for centering at all, and the way that we're now conceiving of restorative justice, for instance, is that space does need it to be conceded in a radically exclusionary way. That people do need to literally shut the fuck up. And, you know, I don't know if that's a good answer or there's some other thing happening here, but I was just wondering, you know.
Did you treat this in the new thing at all?
Yeah, this is in the new thing. It's not a big part of it. It's something I'm sort of putting out there, and that some, you know, some aspects of Plumwood's feminism are, you know, are 90s, and, you know, and the ways spaces of I use restorative justice as a main space for that, where you don't want everyone speaking, and there's a kind of mutually agreed, like, you know, it's not radically exclusive, but it is exclusive. Like now it's time for others to be silent so that the people who have been marginalized come to the center. But that seems to be using the center in a way that she says we shouldn't use it ever. And that has been worrying me a little bit, unless it's just we can be pluralists and have fun.
Yeah,
I don't know.
both of these,
Right.
I totally need to spend some time thinking about how to. Cause yeah, I mean. Plumwood 35 years ago. So yeah, thank you for raising the point, and I'm going to think about it, but.
I don't see it as, like I said, I don't see it as a TKO of Plumwood's view, but I see that there's got to be a little adjustment or a way to understand that there's a different level operating. I don't know. Anyway.
No, I would really like to see this, see if we can point it out, so think about it.
Excellent.
Yeah, thank you very much,
You're
Leon.
welcome.
Okay, thank you for your question, and thank you very much for your presentation, Thomas.
All right, thank you all very much.